Hey guys, welcome back. Hope you had an amazing weekend. Hope you guys got to watch the live stream videos of your services, either English or Spanish. I want you guys to know we miss you guys a lot. I miss you guys a lot. There's absolutely no desk in the classroom right now. It's totally empty. We've been scrubbing the floor, changing out lights, fixing tiles, getting a lot of work done here. Hopefully, we'll be able to come back to school. We'll be able to hang out in the class for a little bit. But if not, it's gonna stink because the classroom's gonna be really nice and clean for you guys to come. But anyway, let's hope and pray that we're able to come back this school year and meet. All right, let's go ahead and jump right into the lesson. We left off on lesson 79 and we're gonna do the odd problems. We're doing problems 16 through 30. So the second half of our lesson, we're gonna work problems 17 through 29 here on the board. So let's jump right in. Our first problem is 2 1/2 times 1 1/3 times 3 3/5. Give me 1 second. Okay, cool. I was just making sure we were still recording. All right. So we have two mixed numbers and one fraction. So what we need to do first is we need to convert our mixed numbers into improper fractions. The way we do that is we multiply the denominator by the whole number, and then we take that answer and we add it to the numerator. So 2 times 2 is 4, then 4 plus 1 is 5. That gives us 5/2. 3 times 1 is 3, plus 1 is 4, so that gives us 4/3. And then we have our 3/5. When multiplying fractions, we don't need to have a common factor. We can just multiply the denominators and the numerators, and there's no need to change it into a common factor. All right, so one way to do it is you can take 5 times 4 times 3, which gives you 60, and 2 times 3 times 5, which gives you 30, and work it out like that. But it's important that you see our cross multiplication, okay? So here we have a numerator 5 and a denominator 5. 5 goes into 5 one time evenly. So these cancel out, and they're represented by 1. You can write a 1 above it. And then you have a denominator 3 and a numerator 3. 3 divided by 3 is 1. So we go ahead and cancel those out. Now we have 2 and 4. Well, if you were to divide 4 by 2, you would see that 2 goes into 4 2 times evenly. So that turns into 1, and 2 goes into 4 2 times evenly. So instead of multiplying all those numbers together, we've canceled out the numbers, and now we can do 1 times 2 times 1, which equals 2, and 1 times 1 times 1, which equals 1. Okay? So even if we were to work it out like this, 30 goes into 60 2 times, or if you want to go this route, cancel out the zeros, 3 goes into 6 2 times. Okay? So our final answer, either way you work it out, is 2. This is just a simplified way of doing it, canceling out numerators and denominators. Okay? When you see a fraction, it's division. Okay? Just think division. Okay? You can write 5/5 like this. Okay? And 5 goes into 5 one time evenly. Okay? This is important because in lesson 80, we're going to be doing a lot of this. So make sure you got that down. Make sure you write all this down. If you need to pause the video because I'm talking too fast and doing this too fast, just pause it. Go ahead and zoom in and make sure you have all this written down on your papers. Because yes, we are going to collect those papers eventually. All right, on to problem 19. Problem 19, we have 1 1/2 divided by 3, okay? So we've got a mixed number and we've got a division problem. Remember, we can't divide fractions. We need to change them into multiplication problems. But the first thing we do is we need to convert our mixed number into an improper fraction. Again, 2 times 1 is 2, and then that answer 2 plus 1 is 3. So we have 3/2. If you have any questions about mixed numbers getting changed into improper fractions, leave a comment below or give me a call or text me. I want to make sure you guys are getting this. So we have 3/2, and my 3, okay, my whole 3 is going to be represented like this, 3/1. Okay, so I need to change my division problem into a multiplication problem. So I change my division sign into a multiplication sign, and then I need to multiply it by its reciprocal. The reciprocal of 3/1 is 1/3. And now I can multiply my numerator by my numerator. 3 times 1 is 3, and my denominator by my denominator. 2 times 3 is 6. But again, if you pay attention, you see a numerator 3 and a denominator 3. These cancel out, okay? 3 goes into 3 one time evenly. So now we have 1 times 1 equals 1, and 1 times 2 equals 2. And you see how instead of going 3 over 6, we jump straight into the final answer. Now, 3 over 6 reduces down to 1/2, okay? So your final answer should be 1/2. All right, next one, we're rounding 0.4287 to the nearest hundredths place, okay? So our 0, there's no value in the ones place, so our 0 is holding the value for the ones place. We've got our decimal. Our number to the right of the decimal is the tenths place. We've got our next number is the hundredths place. Next is the thousandths place, and next is the 10,000ths place. We're rounding to the nearest hundredths place, so we look at the number that comes after it. So in this case, it's the thousandths place. So because 8 is greater than 5, okay, any number that is 5 or greater, we round the number up. So for our final answer, it should be 0.43, okay? And that would be 0.4287 rounded to the nearest hundredths place, okay? Our next question is taken from a graph. We're using a graph of sugar in breakfast cereal to answer questions 23, 24, and 25, okay? So for 23, I just took the graph that's relevant to question 23. So Sweeties contains about how many grams of sugar per 100 grams of cereal, okay? So our graph is represented like this. And if you notice in your graph, each line represents 5. So you've got 0, 5, 10, 15, 20, 25, 30, 35, okay? Sweeties in particular goes up to 35, okay? So you would write 35 grams. Now, it doesn't say 5 or 10, but based on the information on your graph, you can see that this represents the 5 mark. This line represents the 5 mark. So our graph goes up to this mark, so 30, 35. So 35 grams should be your final answer to number 23. Use this information and the information on your book to answer questions 24 and 25. I've got question 25. So write a larger difference problem that refers to the bar graph and answer the question, okay? So your problem needs to be set up something like this. How many more grams of sugar are there in chocolates than good meal? Now, this came from my graph, okay? So take the information from the graph and you need to write a larger, smaller difference problem, okay? So how many more grams of sugar are there in chocolates, okay, than in good meal? So chocolates, there are 40 grams of sugar. This represents my larger. In good meal, there are 10 grams of sugar. This represents my smaller. And the difference, okay, is represented by working it out. So 40 minus 10 is 30. So the answer to my question that I set up would be 30 grams. There are 30 more grams in chocolates than good meal, okay? So you need to set up your word problem. You could set it up not however you want to. You need to make sure it follows this pattern, larger or smaller, okay? So it could either be how many more grams of sugar are there in Sweeties than Chewies, or Chewies than good meal, or Sweeties than good meal. You just use the information on the graph to create your own larger, smaller difference problem, okay? All right, next. Got another fun little graph that I had to draw myself. It's a little crooked, but it's okay. All right, so we're given 3 different points, okay? And I've already plotted them for you here on the graph. It may be a little difficult to see. I don't know if you guys can zoom in on your videos. I don't know if that's even possible on YouTube now that I think about it. Anyway, if you can't, draw on your graph paper. And I'm so sorry about that. We were not expecting you guys to be gone so long. So I only gave you 3 pages of graph paper. If you need any material or paper or pencils or anything at all, please let me know. We'll do whatever we can to make it happen and get that material to you guys. All right, in the meantime, let's go ahead and do this. So I represented my x-axis here, okay? So here's my x, my negative x, and my positive x should be somewhere down here. I've got my y-axis coming down through here, so positive y, negative y, okay? And then I've got my different units all set up here. Our first vertices that we're given is 3, 0, okay? So anytime you're graphing anything, make sure you start from the very center, okay? So I put a little dot right here to signify where my center is so that I wouldn't get confused. So this is 0, 0x, 0y, okay? From here, I'm going to count 3 places in the x-axis. So 1, 2, 3. The reason I went to the right is because 3 is a positive number, okay? I can't go to the left because the left represents negative numbers. So I went 3 places over to the right, and then my 0 represents my y-axis. That means I don't go up or down, okay? It remains in the 0 place, okay? So I plotted that point. So this point here represents 3, 0. Our next point we're given is x3, y3, okay? So I count over 3 places, 1, 2, 3. Again, I go to the right because 3 is a positive number, and then I'm going to go up because it's a positive number. If this were a negative, I would go down, but it's a positive, so I go 1, 2, 3, and I plot my point there. So my second point is 3, 3. Again, if you need to pause the video to mark it on your graph, go ahead and do so. The third point we're given is 0, 3. So I go to my 0 place, okay? So the x is going to be in the 0 place, so I leave that there. And my y is it's 3 units up, so I count 3 units. 1, 2, 3. So I plot my point there. So 0, 3 is represented right here. What they're asking for question number 27 is what is the 4th point in this square? Okay, so right off the bat you see, so 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, now we're not given this point, but you can see based on the 3 points that our graph, that our 4th point is going to be 0, 0. Okay, so the x is in the 0 place and the y is in the 0 place, and that creates, and I'm just drawing over the lines, but I'm kind of trying to reinforce it. That represents our square. Okay, so the final answer to number 27 should be 0, 0. And then we're going to answer a couple more questions based on this graph. You can answer question 28 if you have any problems with that, figuring that one out. Let me know. I'll try to help you. But we're going to answer problem 29 together. So we know that area, to find the area, we need to multiply the length times the width, okay? So how do you find the length? Well, we count the units. So 1, 2, 3. So that's the length. So, and what's the width? Well, we count the units this way, 1, 2, 3. So we take 3 times 3 units, and we multiply it. 3 times 3 equals 9 squared units. Make sure you have this label on it. Okay, 9 squared units, and that's your final answer for problem 29. Work the rest of the even number problems out. You need to plug those into your quiz. Make sure you are doing that. Make sure you are completing your work entirely. Make sure you're reading through all your problems, and if you have any questions at all, please let me know. All right, guys, that's it for today. Yeah. Tomorrow we're going to go into lesson 80, and we're going to do all the odd number problems for problems 1 through 15. All right, thanks.